He's climbing your windows, he's snatching your people up, trying to rape them, so y'all need to hide your kids, hide your wife, hide your kids, hide your wife, hide your kids, hide your wife, and hide your husband, cause they're raping everybody out here. You don't have to call.
Today we're going to be talking about carbon nanotube. One of the forms in which carbon exists in nature is called graphene, in which individual carbon atoms are bonded together in hexagonal shape. Depending on how this is rolled up, we can either have a semiconducting carbon nanotube or a metal carbon nanotube. I'm gonna show.
First, we will go over synthesis. There are three fabrication techniques that we will go over. They include arc discharge, chemical vapor deposition, and laser ablation. The first technique we will go over is arc discharge. It is a type of electrical conduction characterized by high current density and low potential drop. Some of the pros of using this technique include it's easy to produce both single-walled and multi-walled nanotubes. The single-walled nanotubes have fewer defects. There is no need for a nanocatalyst for the multi-walled nanotubes. It's not expensive and it allows open air synthesis. Some of the cons of this process include short tubes and much purification is needed. The next technique that we will go over is chemical vapor deposition, or CVD. It is a chemical process where the substrate is exposed to one or more volatile precursors which react or decompose on the substrate surface to produce the desired deposit. Some of the pros of using CVD include long tubes, it's a simple process, it's scalable, and it's very pure. But one con that comes with this is that there are defects with mostly the multi-wall nanotubes. The last process that we'll go over is laser ablation. And it is the process of removing material from a solid surface by irradiating it with a laser beam. The pros of this process include having a decent diameter for mostly the multi-wall nanotubes. The material is pure and without any defects. But the cons of using this are that it produces long nanotube bundles and it is very expensive. Next, we'll go over a few properties of carbon nanotubes. Some of these include it is the strongest and stiffest material discovered in terms of tensile strength and elastic modulus. There is a low density of 1.3 to 1.4 grams per centimeter cubed. The single-walled nanotubes can withstand pressures up to 24 gigapascals. The carbon nanotubes are good thermal conductors, and the carbon nanotubes are highly toxic. Well, now that you've pretty much learned the basis of carbon nanotubes, the synthesis of how they're made, and the properties, I bet you're probably thinking, how in the heck do we use these things? Well, let's go to Tim to show some of the applications on how you can use carbon nanotubes.
Because of the unique properties that have been said earlier, carbon nanotubes are found applications in sports. Presently now, we have soccer balls made of carbon nanotubes. We have your rackets, your tennis rackets made of carbon nanotubes. We have your baseball bats made of, because of its high thermal conductivity and its high electric conductivity, it is being proposed that someday your transistors will be made of carbon nanotubes as against silicon that's presently being used. Other applications include your drug delivery, because carbon nanotubes, because we can attach chemicals the surface of carbon nanotubes. Chances are your cell phones actually made of carbon nanotubes. No, the batteries of your cell phones or your laptops are made of carbon nanotubes because they are actually super capacitors. They can store a lot of energy compared to what is being used now. So,
well, that's all for our show today. I hope y'all had fun. Join us next week as we talk about halide clay nanotubes, the kind of cousin to carbon nanotubes, you could say. Well, that's it. Have a great day and an awesome tomorrow.